Welcome everyone, I'm Adam. In this problem, we're going to find the standard form of the equation of a parabola with the given characteristics, where we're told that the focus is at point 2, 2, and the directrix is given by the vertical line x equals to negative 2. Now, we're not going to sketch the graph of the equation of the parabola, but it does help to graph some of these things to kind of get a visual idea of what we're looking for. So that's what we have over here. So we have our vertical directrix at line x equals negative 2, and our focus point at 2, 2. Now what this tells us is that we have a vertical directrix. Right off the bat, we know that we have a horizontal axis for our parabola. So with a horizontal axis, that tells us at least what form the standard form of the equation of the parabola is going to have. Namely, we're going to be looking like y minus k squared is equal to 4 times p times x minus h. And one more thing that's going to help us is we know we have a horizontal axis, but the axis is going to be perpendicular to the line x equals negative 2 and going through our focus point. So for right now, we're actually going to sketch that in for reasons why we'll see in just a moment. So I'm just going to sketch what the horizontal axis would be. Again, going through our point 2, 2, perpendicular to our directrix. So that's our horizontal axis. Now, how does that help us? Well, coming back to the standard form of our equation, to find this, we have 3 values we need to put in. We need to find k, h, and then p. So let's start with k and h. Well, those are the coordinates of our vertex. You know the vertex has x coordinate h, y coordinate k. Now, how can what we've drawn help us find that? Now, of course, there's more formulaic way of doing it, but based on our graph here, we can do that. So the vertex, if you remember, it's the midpoint between the focus and the directrix. So it's the point that lies equidistant between the two. So taking a look at this, well, over here our directrix is at negative 2. Our focus is at x equals 2. The total distance would be 4. Half that distance would be 2. So taking the midpoint, or the point that is distance, say, 2 away from the focus and 2 away from the directrix, that looks like we have the point right here. So our vertex is going to be at x equals 0, y equals 2. So let's put that over here. So x equals 0 and y equals 2, or h equals 0 and k equals 2. So that's one step to plugging in to our standard form here. Last thing we need is p. So how can we find p? Well, we know that we have if we have a horizontal axis, then the equation of the directrix can be given as, say, x equals h minus p. But we know the equation of the directrix is x equals to negative 2. So h minus p has to be equal to negative 2. So we'll just plug in for h, which we know. Well, our h is 0. So we have 0 minus p equal to negative 2, and just solve for p. So we just have a negative p equals to negative 2. Dividing both sides by a negative gives us simply that p is going to be equal to 2. Okay, now we have everything, and go ahead and plug it in. So back to our standard form of our equation. So we'll put everything in and then simplify if we need to. So we're going to have y minus k, or y minus 2 quantity squared, is equal to 4p, or 4 times 2, times the quantity x minus h, or x minus 0. Okay, so that would be the beginnings of our standard form, and yes, we can simplify this a little bit. We can write this as quantity y minus, say, 2 squared is equal to, we can multiply our 4 and our 2, which would give us 8, and x minus 0 is just x. So in standard form, we'd have y minus 2 squared equals to 8x. We'll go ahead and box this entire thing, since both are kind of acceptable, since they show all the values. So there's the standard form of our equation. Thank you very much.